In this tutorial, we will find out how much force required to compress the spring 10 millimeter downward direction. So we will see, we will create this spring and we will make all the necessary steps to find out the required force in Newton. First step is prepare the model. So we are going to create the model. Top plane, sketch, activate circle, and here I am going to draw 10 millimeter, enter. Press escape key to out and go to feature, activate here helix and spiral. Now we are going to create a spring defined by pitch and revolution, constant size. Now pitch 7, revolution pitch 3, revolution 7, angle 0, clockwise. Okay, now just activate swift boss base. Now here choose circular profile and here I am going to select diameter 1. You will see. Okay, now I want to trim from both sides so that we will get a flat surface. We need flat surface to move spring up and down, and also we need to fix spring from one side. Go to surface, activate here cut with surface. Now here I am going to select top plane. Now you will see arrow goes downward, say OK, and this is trimmed from back side. Let me hide, click and hide spiral. Now let me create a plane, reference plane, top plane, and height is going to be 21 because 7 into 3, it's, you will see this is going to be lies at center. Okay, no, let me check spring look. Okay, sweep cut with surface. Now see the arrow is goes downward, simply reverse direction, say OK. Look, let me hide. Okay, second step for simulation is apply material. So I am going to apply material for spring. Right click, edit material. Now this time I am going for DIN standard material. Now here you will see DIN is steel, stainless steel. Now here I am going to apply this 1.43108 18 into 8. This is the material for a spring. You will see all the properties here. Once you click apply, material will change. Okay, that's it. Now go to SolidWorks add-ins and here select SolidWorks Simulation, and it will take few seconds to appear here. Just wait. Okay, the simulation tab appear. Now here select new study. Now I am going to give the name spring force, because we are going to find out how much force required to compress the spring 10 millimeter downward direction. Okay, now this study is about linear study, and select static, not dynamic. Say OK. Okay, now we already start third step we already taken is start simulation study. Now the fourth option, this is single procedure body, so we don't need connections. Fixture, you will see if I am going to just see material already applied. Right click, fix geometry. Fix geometry. Now the base we are going to fix, so we are going to select this one and this is going to fix. Select OK. Now I want to compress spring from top face to downward direction, so we need to apply one more fixture. You will see here fix advanced fixture. Okay, now simply choose on flat face. Now select the face, so I am going to select this face, come down, normal to face. This is the 10 millimeter reverse direction. See, arrow goes downward direction, and activate these also. Direction 2 keep 0, direction 1 also keep 0. See, direction 1 0, direction 2 0, direction 3 10 millimeter downward direction. Variation with time linear. translation dimensions millimeter. Now say OK. Look. Now right click on mesh, create mesh. Now here I am going to keep standard. If you drop down, you can change the size of a mesh, but we will keep as it is. We are not going to change anything. Say OK. Now it will take few seconds. Just keep hold. Now you will see there is a fine mesh. These triangles are elements mesh, and these dots are, there is a small dots, and these lines are element. See, if you keep finer side, you will get accurate result, but it will take too much time to calculate. So I keep on mid, no fine, no coarse. Okay, now the next step is step number 7. Run this. Say OK. There is a small error, but let's see what will happen. Now it may take time because our cores are finer, and you will see, just take here and see, this is going to calculate. See, this is moving toward downward. It will calculate, and definitely it takes time. Now we are done here. You will see 3 types of, by default 3 result: stress, displacement, strain. I want to see displacement. So right click, show. See, even though right click and here choose chart option, and here activate max and minimum annotations, and even though, see, these displacement in millimeter, but it is in scientific way. So let's come down here, change floating. Say OK. Look how much displacement, maximum displacement 10 millimeter, what we actually feeded. Minimum displacement 0. Okay, even if you want to see animation, just make little animate, just make little slower. Now again it will calculate, and see, you will see the color going to change, and you will realize the displacement. Okay, even though show animate, now you will see stress. Now actually we want to find how much force required to compress the spring 10 millimeter downward direction. So in result, right click, and here you will find option list result force. Okay, now what options? Reaction force. I want to find out reaction force. Now here in selection we have to select the faces plane which is going to fixed. So this bottom face, this is going to fix. Okay, now this one plot step, everything keep as it is. Now here select update. Now you will see the result. Now resultant 14.47. This is actually the force required to compress the spring 10 millimeter downward direction. Now here you will see response graph. Now click and you will see, just take bigger, or let's expand. Now see some Y. See this graph. If you select, go move your cursor near edge, and you will find here, see at bottom mid, let's me check, try to keep near on the edge. See, it seems 14.45 something. So this is how we can find maximum force applied to compress the spring 10 millimeter downward direction. I hope you like it. If you want to save this graph, just simply click and save. Don't forget to share and like our video, and please subscribe our channel for more video and more projects in SolidWorks. If you want to hide this, simply right click on fixture, hide all these symbols. Thanks for watching.